analysis you want on your data. Apart from that, in MATLAB we can create apps also. So we can create apps, we can create a .exe file as well for that. Okay. Further, whatever algorithm you developed, if you want to share it as a PDF, that also you can do. You can create as a doc file, or if you want to publish on website, then you can create a .html file also for that. Apart from that, if you want to interface your algorithms, or if you want to deploy your algorithms on hardware, that also we can do. Okay. And if you want to interface your algorithm with other languages, so very easy way, you can create a .exe file, you can create a Java library, you can create a C++ library. After generating the library, you can interface with other languages as well. So that is a complete technical computing workflow of MATLAB. Let me switch here in MATLAB first. Okay, this is a MATLAB environment when we open the first tab. So this is a command window. So if you want to visualize any data, if you want to execute any file, just type it here and enter it, you will get the output here. Like I defined a is equal to 1:20. So minimum value is 1 here, maximum value is 20, and step size is 1 as a default. Okay, let's say if you want to provide some step size also, like I am going to provide here colon 0.1, then colon again. So first value will be 1 in this case, second value will be 1.1, then 1.2, 1.3 till 20 like this. Okay. Okay, this is a current directory, or you may say it is a current working directory of MATLAB. So any file, if you want to execute in MATLAB, or if you want to save any file, as a default it will be saved as in a current folder. Or if you want to execute any file, your file has to be in a current folder. Okay, now here you see that is a workspace. Like I define this variable a, as a default it will be saved here in a workspace. Okay, later we will discuss that what kind of this import tools are there and what kind of other tabs are available. Okay, so if you are a beginner of MATLAB, let's say that you don't know anything about MATLAB. So this is in MATLAB, one thing is very important, how to get help in MATLAB. So first of all, we will start that how to get a help in MATLAB. Okay, so one way to get a help here, just click here in FX. Okay, now let's say if you want some kind of fast Fourier transform or some kind of trigonometry, let's say I want a sine of some data, just simply here I will type here sin sine, and I will get this functions here. See, right, y is equal to sin x, and here it is explanation that what is this and how you are going to use. If you are not happy with this help, just click here more help. When I click here more help, I will get a document of that, and you see that for this function how to use this syntax, further descriptions of this function. If I scroll below, you can see that some examples also, that how it works, right? And if I more scroll below, here you can see that what kind of algorithms are used for this. So any kind of function, if you know, but if you don't know how to use that, just type it here, you will get the help. Second way to get help, let's say that I don't know how fast Fourier transform works. So simply I will type here doc FFT, and I will get a fast Fourier transform document for that. So here you see that how to use this syntax. Below, these are explanations how you are going to use. More below, if I go, you can see some examples also that how it works, right? Other way, let's say I want to know, as you know that there are more than 100 toolboxes available in MATLAB. Either you are working on communication, you are working on DSP, someone is from electrical department, someone is from mechanical department. For every department, toolboxes are available in MATLAB. But I want to know how many functions are available in any specific toolbox. In that case, just click on this question mark. Fine. Hope my voice is visible. Sir, my voice is visible. Sorry, my voice is audible. You can write in a chat box that is it audible or not, my voice? Okay, fine, fine. Okay, so just I clicked on help here, and now you see that group wise toolboxes are given here, right? I want to know how many functions are available in core fitting toolbox. Let's say just I will click on this. Here I will click on function, and you can see that how many functions are available group wise. Like for interpolation, if you want to do interpolation, you can use these functions. If you want to do smoothing of your data, you can use these functions. Now when I click on any function, you will get the explanations and helps also for that function, right? Here like this. Okay, this was about the help, that how you can get help in MATLAB. More we will discuss during the session. This is the basic MATLAB, just a basic. Any toolbox if you want to access, you require this MATLAB platform. So if I click on this MATLAB and I want to know how many functions are available in this MATLAB, just I will click here and I will get all the functions which are available in basic MATLAB, like entering the command groups, matrices and arrays. And if I go more below, here I can see some other functions like group creation properties. Now if I go more above, if I scroll like this, like if I have to create function handle, if I have to create map containers, these functions are available. If I am working on time series data, then how to create a time series data, you can get help like this in MATLAB. Okay, fine. We will start from very basic. So first what I am going to do, how to create a 2D equation and 3D equation, and further we are going to plot. Okay, so for this what I am going to do, I have two options to do this. Just hold a minute, 1 minute. Here. Okay, I have a two option. Either I can write my mathematical equation in the command window, but if I write my equation in a command window, I will be not able to save it. But if I scroll this arrow up and down, I can get the history from that. Other way that I can write in a script file and I can save it also. So here you see in a script file, we have two options, new script and new live script. If you use these new script files, you can write your codes, you can execute your codes, but output you can't see in the same script file. You require a different figure window to see your figures, or output you can see from this workspace. But if I use live script, here I can write my codes also and I can visualize my output as well. Okay, so let's start from here. I am going to start from 2D. Okay, here let's say I have to write some code, text. So I will select text from here, and here I am going to write a simple plot, and also I am going to make it as a heading and bold. Next I am going to write a code here. I will select code here. Fine, just 1 minute, some noise are coming. Okay, fine, no noise. Okay, just 1 minute. My voice is coming, right? My voice is coming?
No, sir.
Okay, it's coming. Fine. Okay, I was here. Now we will start from 2D equation. So for 2D equation, we require two variables, one dependent and another independent. So first let's define the independent variable here. So let's say that independent variable is t. T is equal to, two ways I can design a vector here. Let's say I am starting from 0, and my step size is 0.1, and total number of elements I am going to take 20. That is by t. That is a vector. So in a MATLAB, if you have a single row or single column, that is called vector, or if you have a single value in your matrix, that is called scalar. Okay, So later we'll see that how access matrices and how to apply operators on matrices also after this 2D and 3D plot. Okay. Next I have to define my y-axis. Let's say it is y is equal to some equation. Let's say I want sine into t. Now further I want to plot it also. So simple command, plot x-axis, that is t, and y-axis, that is y, right? Now if I click this blue strip here, this blue strip which you see, when I click on this, I will get the graph of that. So you see here, I can visualize my numeric data also here. Also I can visualize my plot as well. Both together we can do it here. You see that this is the plot here. Now further what I want to do, here you see that as a default frequency is 1. What I want to do, I want to change the frequency and I want to check my graph. Okay, so here let's say f is equal to some values. Let's say it is 10, and here I want to multiply this f with t. So for multiplication we use in MATLAB asterisk sign. Very simple. So now when frequency is f 10, then what is my graph? Okay, this is for the single value. Now let's say I want to check on multiple frequency that what kind of graph I will get here. Okay, so for that we don't have to use any kind of for loop. Just go in live here, insert, and from here control, I am going to use a numeric slider for that. Fine. And here it is asking me what will be a minimum value of this slider. Let's say minimum value is 1, maximum value it is asking, that is 50, and it is asking what will be step size. Let's say step size is 1. Okay, done. Now you see when I change this value of f, my graph will be changed here. So you see that how easily this kind of checking we can do using live script. We don't have to use any for loop for that. Now you see when frequency is 7, I am getting this perfect sine wave, right? When I increase this frequency, now you see that my sine wave is here. It's not look like a sine wave, right? So what is the reason that when I increase the frequency it is not sine wave? So you know that a sampling frequency have to be double or more than double of signal frequency. Then only you can do a sampling. So whatever I am representing here, it is following the sampling theorem. So that's why it is overlapping and it shows like this. And when I decrease this frequency value, and I will get the perfect sine wave. See. So always remember when in any software if you are using, if you don't follow the sampling theorem, you will not get the perfect wave in that case. Okay, this is a 2D plot. Now I don't want to execute this again. For that I can break it as a section. So you see that there is an option to break it as a section. Now I am going to do a 3D plot. So I am going to write a text here. Simple 3D plot, and I want to make it as a normal heading, and I want to make it bold also. That's all. Now here when I have to write the code, I will select this code option. Fine. Now I am going to write a code for 3D. Now you see here we have t also, we have y also here. We require just one more equation, like we have x-axis, we have y-axis, and we require a last z-axis. Let's say z-axis is z is equal to cos t. Very simple. Now I have to do a 3D plot. For 3D plot we require a x-axis, y-axis, and z-axis, and we have right now. So here you see simply I will use plot 3. X-axis, let's say it is t. Y-axis it is y, and z-axis is z. Let me run this because I changed the step size here, so I am going to run it again. Okay, now if I plot this, I will get the 3D plot. See, that is a helix, right? If I want to plot cos theta with respect to sine and simple array, line array, I will get the helix in this case. Further, I want to know that what is this? This is x-axis or y-axis So we can do a leveling also to identify that which is a x-axis, which is a y-axis, and which is a z-axis, right? So here we use inbuilt function in MATLAB, that is x level, y level, and z level. And you see that here just I type XL, I got the some options here, some whatever files are available by this name it is showing you. So I require a x level, let's say it is x axis. Now you see here one thing more, when I am using function I am using parenthesis bracket. So in MATLAB when you are going to execute any kind of function you have to use a parenthesis bracket for that. Okay, so same thing I am doing here. X level is also an inbuilt function in MATLAB. I am using parenthesis bracket, and now further I am writing a character here. See, this is a character, right? So whenever you write a character in MATLAB, always use a single inverted comma for that. Okay, now I am going to define a y level, that is y axis. Further I am going to define a z level. So here you see that there is a spelling mistake. Even if I do a spelling mistake, MATLAB will let me know that I have a mistake in this line, please correct it. Okay, z axis. Now if I run, I will get x axis, y axis, as well as z axis too for that. Okay. Fine. Now next. Okay, this was whatever plot which you saw right now, and whatever I have shown here, shown that were line plots, 2D or 3D, that were line plots. Next we are going to do a surface plot. You will see that how to do a surface plot, contour plot also. So in this case, let's say I am going to do a surface plot of a cylinder. So what can be an equation for a cylinder if I have to do a 3D plot of a cylinder as a surface? Circle equation, and if I put multiple circles on z axis, I will get a cylinder, right? Circle, one circle, then another circle. If I put multiple circles on z axis direction, I will get 3D cylinder, right? So here what I am going to do, and first of all here I will design the theta circle. The angular distance will be 0 to 2 pi. Here I am going to use lean space to create a vector. This is a linear spacing. Minimum value is 0. Minimum value is 0. Maximum value is 2 into pi. Okay, 2 pi. In MATLAB, to write a pi we use pi. So minimum value is 0, maximum value is 2 pi, and between 0 to 2 pi how many number of elements I want, means in how in what part we are going to divide, means in how many parts are we going to define between 0 to 2 pi, or you may say divide. So let's say I want to divide in 20 parts. Okay, we have theta now. For circle, radius will be constant. Let's say that radius value is 5. Okay, theta, we have r. Now we have to define the height of cylinder. Let's say height is varying from 0 to 5. Okay, as I told, I don't want to do a line plot. I want to do a surface plot. In that case, this vector will not work. So we have to convert in a grid form. Grid is what? That is a repeated value. Okay. So in MATLAB there is an inbuilt function that is called mesh grid. So here theta and h. Now you see here, theta is a vector. Total number of elements are 20 in this case. R has only one value. So it is a scalar. So we don't require to convert any scalar as a grid form. We require to convert vectors in a grid form. Okay. So let me write it this, then I will explain that actually what is this. Okay. Mesh grid of theta and h. So what is happening in this case? I am first defining the vectors, and I am converting as a grid form. Theta will be converted as a grid and it will be saved here. H will be converted as a grid and it will be saved here. I want to check it, debug it. For debug it, let's say I want to hold my this execution at line number 30. Just I will click here. Okay. Now further I am going to run this. So it is holded here. You see at line number 30. Now if I move my cursor, you see that theta is showing vector 1 to 20 value, right? Same for height also, you see that value is saying 1 to 6. Now if I move one step ahead from here, there is an option to move one step ahead here. So if I click on this will be executed. Okay, there is a spelling mistake. Now it is corrected. Fine. So if I run this again, so it will be holded here. It is hold here. Now I will click one step ahead here. Now you see theta is converted as a grid form. So nothing, it is just a repeated value 0 0 0 and further whatever is the next element that is repeated, then third like this. Okay. So now you got that what is a mesh grid actually. Now we are going to write an equation for that. So first of all I will write circle equation. What will be a circle equation? X is equal to r cos theta, y is equal to r sin theta. That will be a circle equation. Okay. So here I am going to write first of all x is equation, that is cos theta. Then y is equal to, that will be sin theta. Sorry. Okay. Just wait a minute. Okay, here you see here we have a circle equation. X is equal to r cos theta, y is equal to r sin theta. Further we require a height, so we can put multiple circles on a height. So z will become height. Now we are going to plot this as a surface. So plot as a surface, simple, we use a surf command, x, y and z. This will be a surface plot. Next I want a mesh plot, x, y and z. Fine, we have a surface, we have a mesh plot, and the last I want to do contour plot. So I will explain that what these plots are available. Just see here what I am doing. And I want the 3 contours here. Simply I will define the 3 values. Now I am going to run this section again. So you see that first is a cylinder, that is a surface plot. It is not filled. That's why we say that is a mesh of it. That is a mesh. Third one is contour. In contour, you can define how many number of circles do you want. How many number of circles do you want? Here you see that I provided value 3 and I am getting here 3 circles. Okay. So this was about how to use a live script to write your algorithm, and which you saw 2D plot, 3D plot and surface plot. Next step is, if I have to save this all by algorithm, or you may say with these figures and these codes as a PDF file, just simply I will click here export to PDF. And you see, let me write here, that is my PDF here, right? So when I save this, it will create a PDF file and the PDF name will be my PDF. So it will be saved as a default in MATLAB here somewhere. So it is still creating. Now you see that here my PDF is created, right? When I open this outside the MATLAB, a PDF is created for that. See, whatever I did there, proper PDF is created and I can share with my colleagues as well. Okay, next I am switching here again, and you see that lots of options are there. How are you going to save this as a PDF, or if you want to export as a Word doc, means Microsoft Word document, or if you have to publish on your website, you can create a HTML also, or you can convert all these algorithms as a latex as well. Okay, now this was about 2D 3D plot. Next I am going to switch here in MATLAB command window. Some matrix operations I am going to show you. Okay, manually if I have to create some kind of vectors, how we can do it? Very simple. This is my variable name where I am going to save my vector. A is equal to some values here. Simply, you may use comma, you may not use comma, still you will get the same answer. So I am using the comma, so I will get the A. That is my A. Okay. This is the way how you are. This is a, just wait. So kindly mute yourself during the session. Okay, now it is fine. Let me mute her. Who is playing music? Let me check. Okay, this is the way how we are going to create a vector. Fine. If I have to create this is a row, right? A single row with 6 columns. Let's say I have to create a single column. So how we can do that thing? B is equal to, let's say my first value is 4. This is my first row. If I have to create a second row, I will use semicolon. Then next value, semicolon, next value, semicolon, then again next value, semicolon, and the next value. In the last you are not going to use semicolon. So it will create a single column with 5 rows. So this is the manual way how you are going to create. Otherwise you saw linear spacing, or simple this colon sign, how to create it, right? Okay, so you see that how easily this kind of things you can do in MATLAB, right? Now how to create a matrix? Let's say I have to create a matrix of 3 into 3, a square matrix where rows are 3 and columns are 3 as well. So here first of all I will define my first row, then I will use the semicolon, right? Who is playing music? See, if someone is playing music in known, I have a software actually here, this one. Later I will get the IP as well as, I am talking to students. I will get the name as well. So please don't play any music, okay? So okay, I was talking about how to create a matrix of 3 into 3, right? So this is my first row. Second row will be like this, and let's say change some values, and semicolon. Third row, that's all. So this is the matrix of 3 into 3. Instead of creating this real values, you can provide some kind of complex value also. So in MATLAB, if you write minus I or minus j, it will take as a complex. So you see that all values are converted as a complex, right? So here, because here I provided a minus I, this third one, minus I, that is a complex, right? If you want absolute value of this, just simply give a command abs, you will get the absolute value of that, right? So this is the way how you can create a matrix. Okay, let me define again. This is my matrix A, and second row, let's say it is 1 2 3 7 1 2, and third is 4 6 and 0. This is my first matrix. Second matrix I am going to create using magic command. This is an inbuilt function in MATLAB to create a square matrix. If I give a command magic and input arguments 3, it will create a square matrix for me. Minimum value will be 1 and maximum will be square of input arguments. So it will create a square matrix where minimum value is 1 and maximum is 9. Okay, I have a two matrix here, A and B. How to do a matrix multiplication? Very simple. A for multiplication we are going to use B. A into B, that will be a matrix multiplication. If you know the matrix rule, the number of columns of the first matrix have to be equal to the number of columns of the number of rows of the second matrix. Then you will be able to multiply. Okay, again, this is my A, this is my B. I want to do an array multiplication. Array multiplication means an element of first matrix will be multiplied with the corresponding element of the second matrix. So 5 into 8, it will be 40, 6 into 1, 7 into 6, 36, something like that. So instead of A asterisk B, we will use A dot asterisk B. The same reason, you see 46, 42 means an element of first matrix will be multiplied with the corresponding element of the second matrix. So in that case, you will use dot. Either you are doing an array multiplication or array division, depends. Okay, this is my A, this is my B. I want to divide A by B, means matrix division. First I am going to do A divided by B. That is a matrix division, A divided by B. Okay, so this result you will get when the condition of matrix division will be satisfied. Fine. Now again, array division means element of A will be divided by element of B, then 6 will be divided by 1, 7 will be divided by 6. We will use A dot slash B. Very simple, right? Okay, this is my matrix. I want determinant of the matrix. So simple command is there in MATLAB, that is det and A. You will get the determinant of this. Fine. I want rank in this matrix. Rank is very useful, right? So if I give this command, total rank is showing it is 3, right? I want max value in A. In this matrix, what is the max value? See here, is simply if I give a max of A, it will give me a max value column wise. You see that in A, in first column max value is 7, right? In second column max value is 6, so we have 6. In third column max value is 7, so we have 7 in this case. Now I want the max value from whole matrix. How we can extract the max value from this whole matrix? So very simple again, max, then again max, and your matrix and bracket close 2 times. Fine. Max of A, then again max of it, so it will be 7. Same if I have to find out the minimum value, mean of A, then mean of this, and I will get the minimum value whatever available in that matrix, that is a matrix of it. Now this is my matrix. Any kind of data when you export in MATLAB from any software, or you want to going to import in MATLAB, very simple. So as a default, it will be saved as a matrix. Now I have this matrix here. Fine. Let's say that I am working on signal processing. I imported data, I have signal processing. If I am working on signal processing, then these matrix are samples for me. I have this matrix, I have 3 signals, 574 samples of first signal, 616 samples of second signal, and 720 samples of third signal. If I am working on image processing, the same matrix is an image for me. Let's see. First of all, I am going to give a plot command of this A. I will get 3 plot here. See, 3 plots I got. First column, second column, then third column. If I am working on image processing, the same matrix will be an image for me. See, image of A, and I will get the image of it, some color based on the index of that. Okay. So what I want to say, depends on you on which application area are you working. According that, your matrix will be changed as well. Okay. So you got that basic operations on matrix, addition, multiplication, division. Addition is very simple. This is my A and this is my B. Simply A plus B, it will be addition of it. subtraction a minus b, it will be a subtraction of it. So these are very easy operators. And if you want to know that what kind of operators are available in MATLAB, just simply you have to give a command helps ops and will get the all the operators, sorry, ops, that is helps, not helps, it is help. So help space ops and you will get all the operators which are available in MATLAB, like addition, subtraction, matrix multiplication, matrix division. You see here all these operators are given here. Like if I click on plus sign, it will give me that what is this plus and how it works, right? Okay, fine. Okay, this is my matrix. Again, this is my B matrix. Now we'll see how to apply logical operators on that matrix. How to apply logical operators on matrix. If I am saying here, I want value of A which is greater than 5, or value of A which is greater than B. First of all, let's see this value of A which is greater than 5. Simply value of A which is greater than 5, and you see that these are the values from this A matrix which are greater than 5. Very easy. I want value of A which are equal to 5. Sorry, double equality, that is the operator, right? Operand we are using, logical operators we are using. So only one value is there, that is a 5 which we got it, right? This is A. Now I want value of A which is greater than 5 and smaller than 7. So you see here, for AND we use the AND operator here. Oh sorry, here I forgot the giving the value A. So A is greater than 5 and A is smaller than 7. Now the two values are there, that is 6 and 6. In a single line you can apply this kind of logical operator. Okay, this is my A, this is my B. I want value of A which is greater than B. Value of A which are greater than B. If I run this, wherever these conditions are satisfied, I will get value 1, else I will get 0. So what I did here, value of A which are greater than B. So A greater than B, and what that values are there, just simply A and this logical index, that as a default it is saved in answer. So I will get all that value, that is 7, 6, 7, right? So either you are comparing with two matrix or you are comparing with a single matrix, single vectors, you have to use this kind of operators. Now say I want A in bracket, A is greater than 4, or for or we use this sign, or A is smaller than 5. Okay, A is greater than 4 or A is smaller than 5. I will get all these values. A is greater than 4 and A is smaller than 5. Or I can see A is greater than 4 or some other operators, or A is equal to 5, or A is greater than 6 and A is equal to 5. So like this you can apply operators also. Fine. Okay, we saw that okay, let me summarize what we saw actually right now here. We saw 2D plot, we saw 3D plot, also we saw surface plot, mesh plot, and different kind of other plots also. And apart from that, we saw that how to apply operators on matrix, plus we saw how to apply logical operators also, right? Next which we are going to see that some without writing a code, if I have to plot something, how we can do. Okay, let me define some data here. X is equal to, again I am going to use lean space, and some value here from 0 to, let's say I am going to take 20, and total elements I am going to take 100. So what it means, lean space, that is a linear spacing, minimum value is 0, maximum value is 20, because between 0 to 20 we are going to take 100 elements. So that is my x-axis. Okay, simply y is equal to, I am going to define exponential. So in MATLAB To write exponential we use exp. So from where you will get these functions which I am using? So I told you, you can click here, you can search it here, or just go in the help, and from here you can get that what kind of functions are available here. Fine. Okay, just wait a minute, some noise are coming, let me mute. Fine. So in this case we use AEXP and X. So we have an exponential here. I am using semicolon because I don't want to see output on my command window. Okay, that's why I am using semicolon. And whatever variable I am defining here, as a default it is saved here in the workspace. So if I click on any variable, it will open a new window for me, and where I can check that what kind of data we have, right? Okay, now I don't want to write a plot command for that. Simply I want to plot from here. So I am going to select x-axis using control command. I am going to use C, control tab, and select your variables which you are